Hello everyone, this is just going to be a short video on how you can draw different isomers when you've been given a chemical formula. So the different types of isomers and ways in which you can identify them. So firstly, what are isomers? Isomers are compounds with the same molecular formula, so that means the same number of carbon and hydrogen atoms, but they have different structural formulas. So that means the way in which those carbons and hydrogens are connected to one another is different. You need to know this definition. Isomers are compounds with the same molecular formula, but a different structural formula. And isomers may be part of the same homologous series, but they are often parts of different homologous series. And isomers always have different physical properties from one another. So that means things like melting and boiling points and their ability to dissolve. So we're going to look at the different types of common isomers. So the first type of common isomer is just moving a branch. So if we label this chain from left to right, we can see that we have 5 carbons, and on the branch on the left-hand side is on carbon number 2, which makes it 2-methylpentane. The branch on the right is on carbon number 3, and that's 3-methylpentane. Now you might think, why can I not add a branch on carbon number 4? Well, if you've put a branch on carbon number 4, you want the branch to be on the lowest number possible. So if it was on carbon number 4, you would end up having to count from the right-hand side to the left-hand side, and it would end up actually being on carbon number 2 instead. So 4-methylpentane is exactly the same as 2-methylpentane, and so we want the number to be as small as possible, so we only use 2-methylpentane. Another type of common isomer is moving the functional group, and this is very similar to moving a branch. So for example, for alcohols, if we number our chain from left to right, we can see that there are 4 carbons, so this is butanol. And on this one, we've got the alcohol on carbon number 1, so that's butan-1-ol. On the right-hand side, we have the alcohol on carbon number 2, so that is butan-2-ol, not butan-1-ol, sorry about that. The same thing happens for alkanes. So remember, you always have to write on the lowest number carbon that is part of the double bond. So again, 1, 2, 3, 4. The lowest number carbon for this chain that's part of the double bond is carbon number 1, so that is but-1-ene. And here, for the one on the right, simply moving the double bond across, the lowest number carbon that has a double bond on it is 2. So but-1-ene and but-2-ene are isomers of one another. Another common type of isomer is alkanes and cycloalkanes. So for every alkane, for example, but-1-ene or but-2-ene, if you break the bond here and then connect the carbons around, you end up with cyclobutane. And these are isomers. You can see each one has 4 carbons and 8 hydrogens. Cyclobutane is always an isomer of butane. Cyclopentane is always an isomer of pentene. And cyclohexane is always an isomer of cyclohexane. The final but more slightly complicated method is if you've got a chain, to make an isomer, you can shorten the chain and add a branch. So for example, here we've got pentane, which has 1, 2, 3, 4, 5 carbons. If we take this group off the end and switch it with this hydrogen here, we can turn it into this molecule here, where we've got a methyl group on carbon number 2, but the chain has been smaller. So pentane and 2-methylbutane are isomers of one another. Importantly, when you're adding a branch, you cannot add a branch to the end of a chain. So you cannot add a branch to carbon number 1, and you cannot add a branch to whatever the final carbon is in the chain, because that's not a branch anymore. That's just you moving the end of the chain from one end to the other end. So you can only ever put a branch on carbon number 2 or 3 usually to make these type of isomers. So that's been a short video looking at the different ways in which you can create isomers once you're given one structure. Hopefully now you'll feel a bit more confident when it comes to identifying isomers and being able to draw isomers of different chemical formula.